Okay, so looking at this situation, this is the arc of a piece of chalk that I'm trying to get into a trash can out here that's 1 meter high. Release it from 2 meter height. That's not quite right, but I chose round numbers, about 1.8 meters. Okay, I just made up a function that I thought would get there in a reasonable distance, okay? And I just predicted what the vertex would be. I wanted the vertex, the high point, to be 3 meters away from me, about 10 feet, okay? Puts me a little closer to the other end of the room where I can't throw it that far. Probably can't, but the shoulder's bad. Okay, so I did a horizontal shift of 3 from the basic function. You can identify that, it's right there, staring in the face, smiling at you. And I vertically shifted 47. And then I used the known acceleration of gravity because I knew that would work there, but that's physics, you don't have to worry about why I did that. Okay? But that's a vertical stretch. Okay? If we were on Jupiter, I'd have to use a number about 4 times, 5 times higher than that. Okay? And I wouldn't even be able to lift my arm. Okay, some of you might. So I took all that into consideration, made up this function. It's kind of a ridiculous function because where's the vertex? It's at 347. That means I'm going to have to arc this thing to, from, right about there to the trash can. It has to go 47 meters high. That's about 150 feet. Can anybody throw anything 150 feet high? Can anybody kick anything 150 feet high? You ever watch a pro kick a ball, punter?
There's a special frisbee. It was made to be thrown like that.
That's cheating. Okay. Special frisbee. Using technology to do something you should be able to do with sticks and rocks. That's what we want to do. Okay, well, anyhow, frisbees. Okay. Okay, anyhow, there's our function. It's just simple transformation of the y equals x squared function. Okay. It's got a negative vertical stretch, meaning it's going to open this way. You need to know all that. Anyhow, we take that function now, we're going to analyze it, and I went ahead and expanded this thing using the distributive law, which people are still having trouble understanding. Probably not any trouble understanding the distributive law. Understanding that when I say use the distributive law, that's what I mean. And you're going to lose points if you don't. Okay? So when you take another test, if I say use the distributive law, you darn well better show it to me. Right here it is. X minus 3 squared is x minus 3 times x minus 3. I use the distributive law here, then I got to use it again, then I got to use it again with that negative 5. Well, we got to do all that, but it's very straightforward. We get this, okay? Then we have 2 ways of expressing this function. Now, we want to know what y is when x equals 0. Which form makes it easier to answer what y is when x equals 0? This one or this one? I'd be talking about this or this. What's easier to plug x equals 0 into? Well, I know what you're thinking. This one, and you're right. Because this term is going to be 0 and this term is going to be 0, and you're going to end up with 2. You plug it into here, you're going to have to subtract 3 from 0, which won't give you any trouble. You're going to have to square that, multiply by negative 5, and add it to 47 with 10 times the probability of making an error in some step. So you go with the thing that works. Okay, well, you do that, you find that when x equals 0, y equals 2. So we are at this point. I'm releasing it from 2 meter height. Okay? Then we want to know how far it has to go to clear the front edge of the trash can, which is at 1 meter height. Okay? So you set this function equal to 1, meaning 1 meter, and you get this equation and you solve it. How do you solve this equation? Well, you recognize that it's a quadratic equation. It's got an x squared and an x and a constant term, right? Multiple of x squared, a multiple of x, and just a plain old number. Okay? You want to use the quadratic formula with this because you're not going to be able to factor it. Now, it's easier to solve this equation equal to 1 than it is to solve this equation equal to 1. You can do this without the quadratic formula, but there's something else that might trip you up. So we're going to build the quadratic formula here. We do this, and we recognize that that's a quadratic equation because it has those terms. The quadratic formula applies because we can put this into the form ax squared plus bx plus c. Well, it applies if you can put it into the form ax squared plus bx plus c equals 0. But that's very easy to do. Just subtract that 1, and you've got it. So here's our equation. Okay? We can put it into the form by subtracting 1 from both sides, and we get this. And now we apply the quadratic formula with a being the number in front of x squared, that's -5, b the number in front of x, that's 30, c equal to 1. That must be just fine with that. So there's your quadratic formula. I've also circled the thing for the vertex, the axis of symmetry, the vertex being on the axis of symmetry. Solve that, we get x is about 6 or -0.03, yeah.
On the top one, c's 2.
Top one what?
On the top one, c's equal to 2. So 1, never mind, I understand.
Something about 2.
The top one, 1 is equal to the quadratic formula, and then, so never mind.
Well, the equation is 1 equals this. We have to put it in the form where it's equal to 0.
Okay, I get it now.
So we subtract 1 from both sides. Now we can apply the quadratic formula. We could not have applied the quadratic formula here because it doesn't fit the criterion. Okay? So here's the quadratic formula. You either got to know it or you got to be able to derive it by completing the square on ax squared plus bx plus c. Okay, if you know how to do that, you don't have to memorize it, but it takes a while to derive it, and it's error prone, so you probably ought to just memorize it and use it when necessary and when you're allowed to. If I say you can do it by some other method, you're going to have to. But okay, so there it is. There are solutions. 6 or -0.03, meaning here's our graph again. Here's 1 meter. Okay? It's either 6, it's actually 6.03 if I did my square root of 920 correctly. Okay? Or it's -0.03. That's where the arc of the parabola crosses a line y equals 1 meter. Okay? So we gave them, here's y equals 1 meter on this line. And all we're doing is we're just taking the 1 meter point, moving over and projecting down. You could estimate it, right? Also, where's the vertex? Halfway between here and here, because it's symmetric. We have an axis of symmetry halfway between the zeros, which is why it's -b over 2a, halfway between -b plus this over 2a and -b minus this over 2a. There's our axis of symmetry at x equals 3 meters. How high does the battery rise? We answer that by saying, well, there's the path, the high point's the vertex. We calculate the coordinates of the vertex and find it's 47 meters, which we already knew. But if we didn't already know it, we could have found it. Okay? So there's a lot of information in that problem. It's one very typical type of application that you could expect on like a midterm test. Okay? Not on the full version of the major quiz, but coming up, so take a lesson.